Hi, this is Jim Lewis from Model Train Technology. Today we're going to show the whole setup and configuration of non-DCC connections to coil-based switches and how to hook up our Dwarf signal controllers. Now, one of the first things that we have to tackle is controlling the switch and then having a way to detect what position it's in. So that's where our coil detector fits in. And so when the switch changes, it changes. That signal is sent into the signal controller. We have a little connection board here to make that easy. There's a way to do this with small soldering connections with diodes and so forth, or you can use our connection boards, which just means you need a screwdriver to put all of this together. So we have a coil detector for each turnout. We're running on a simple, this is 13 volt DC, and it's got 5 amps, so it's plenty enough to run the coils and the coil detector. And then separately, we're using our power module to mount power the signal controllers, and that's how the light for the fiber dwarfs comes out. All right, so that's the setup. Let's dig right into it, and we'll start with a very simple setup over here and progress our way to this final setup. The first step is to wire up the switches, the coil turnouts with the switch. These are Atlas switches. This is lifelike actually, but we have just a regulated power supply. I like this one a lot. It's got 13.6 volts output, 12 volt output DC, works fine. This has some capacitors in it. It's a 5-ounce supply. So it can power all the turnouts and all of the things connected to the turnouts with no problem at all. Switch on the front side. So that's the first thing. What I've done here is I've just double stick taped this switch to this surface here. It's a pretty simple connection, black in the middle, green and red. And I just drilled a hole, and that wire comes up here and connects to this little switch. And we'll just tighten these down a little bit here. Let's see, let's get that in there. Now, one of the things you'll notice is that I have these lug parts. I have a terrible time stripping this wire and wrapping it around this little screw to get it in. So what I do is I'll just strip this off, solder these little lugs there, and then if I need to switch things around later, it's really easy, particularly if this is some of these connections are under the table. So on the website and at the bottom of this video is a link to the right size that fits this particular unit. Now, the other thing you might notice is, let me move around here and just zoom in a little bit, is when you set this up, this is in anticipation for connecting the coil sensor, which we'll do in a minute. The lug has an upside and a downside, which basically means the rounded barrel at the end. And what I've done here is I faced them down. And the reason I've done that is so that when I have another connection here, it faces up and the two barrels don't bump into each other. So that's just a really small thing, but that makes things easy. And here's the two power wires, red and black, coming from the turnout. Now we'll talk about polarity in a minute as it relates to the coil sensor, but let's just get this working. We'll turn the power on. And again, this is just a slide switch with a momentary push, all right? So what we want to do is go around the whole layout. Let's zoom back out here. And what we've done, I've added some additional turnouts, and I have 2 more switches, one down at that end and one here. So what I'm going to do is just connect them up. Sometimes you can, so there's some screws with a nut that comes, and this will slide underneath this, and you can have them all next to each other. I decided for this demo that I would spread them out, and so I just made these little pigtails, and I'll connect these up. All right, so I'm just going to do that now, and we'll come back when the 3 switches with none of the Model Train Technology parts connected, just the basic switch. Okay, I've connected the pigtails from each of the turnouts switches. There are just 3 here, and I've assembled these. We're going to work with 3 switches today just to keep things simple, but you could extend this on, and we're going to get into interlocking in a minute. But all we have right now Oh, this is loose, a little bit loose. There you go. Isn't that nice? You can just screw these in. Super easy. All right, so there. And I guess I didn't screw these down either. So I took everything apart and let it loose, and I'd forgotten to screw them back down. So, all right, so, and just to show you, I can't do 3 hands, but there's plenty of power to turn multiple switches simultaneously. So that's the basic setup, all right? So now, why we have the coil detector is that once the switch is thrown, there's nothing electronically that lets us know what position the switch is in, right? Nor the switch over here. There's no way we can get a sense of state, what we call that state. So the state is, in this case, closed or thrown to go to the siding. We just don't know what that state is. So the purpose of the coil detector is to convert the action of the switch to a digital signal that we can keep track of. And so we need to give this board some power, and we're going to connect it up with the turnout switch. And so essentially what I'm going to do here is, as I said, I'm going to turn the power off and just connect up these 2 lugs. So the power, there we go. Let's just connect up this guy. Sorry for my hand being in the way there. There we go. There's 1. There's 2. Okay, before we connect anything else, we'll turn the power on, and we have a blue light on the coil detector, and it just happens to be defaulted to green. All right, so we'll turn the power off again. And now what we want to do, so we have black is common, black is in the center here, and that's a ground connection. And on this switch, the black wire goes to this top part, and the red is to the lower section. You can see that all the way across. And there's a reason for that. It does matter the polarity of how the power is going through this circuit to make sure the coil detector works. And we'll demonstrate reversing that so you know what the symptom is if it's not working. So all I'm going to do is there are 2 wires coming off the left side. So this is the input side, and this is the output side where we're going to hook up the signal wire. So the first thing we'll do is just loosen this red one a little bit, connect this up in here, loosen the green one. Happens to be a black wire connecting, that's fine. Okay, let's turn the power on. And you can see we've got power to the coil detector, it's green. Now if I change the direction, you see the green and red light switching back and forth. So now it's red, and I can move this anywhere as long as I don't hit the switch, turn the switch, nothing happens, right? So this will keep track of the direction of the switch, all right? So it happens to be red. I'm going to turn the power off, and now the power's off, we've gone away, we've left every layout there. When you turn the power back on, the coil detector will remember the direction of the turnout. That's really cool, because then all your signals, you don't have to exercise the signals off, left and then right to get them all lined up. It remembers that. Now I'm using just a protocol here where the red is thrown, so that'll be turning to the right, and the green is straight or closed, all right? So it doesn't matter. Now, if you find out the green light and the way you want the turnouts here, and actually the signal coming out is reversed, you can reverse the wires at the coil here so that the switch goes the opposite direction, or the same wires on the turnout here, or you can reverse the red and black wires here. So you can move them around to make sure you get the orientation of the coil sensor and this properly. Okay, what I've done now, and we'll zoom in a little bit closer to this part. Remember, you see this is the red on the bottom part of this switch. Well, you can see that I've reversed the input, the power supply side. This used to be red and this used to be black. Which direction this supply wire for the coil doesn't matter, but it does matter how the rest of the circuit's connected. When I touch this, you'll notice that the coil detector is flashing back and forth. That tells you that the polarity into this switch and through the circuit is backwards. So if it starts flashing back and forth like that, then just all you do is take the wires from the supply side going in and you just reverse them. So essentially the plus side is going to be on the bottom of the switch and the minus side is going to be on the top of the switch. And let's just put these back connected in. Let's get that one in. And it's flickering because of this. There's actually a little bit of, so the power supply is off. You see the lights going on because there's some capacitors in the power supply. So that's not a problem. It's very, very small amount of current, so there's nothing to worry about. Let's clean that up a little bit. Okay, turn the power supply back on, and now you see it's green, red, green, red. All right, so that's the first step in setting up this whole system. And what I'm going to do is just simply add the other coil detectors to the other switches. I've finished connecting the other two coil sensors. I just repeated the process, power in here, plus side on the bottom of the switch, and then wired out. And out at the switches, I just have it going underneath the three wires here. These are the wires that come with the switch, and they're just coming out of this hole from here to this hole, just kind of keep it clean. So let's turn the power on. And so we've got that one working here. We had this one working, and we have this one working here. So straight is green, thrown is red. Okay, that's the same there. Then let's try it here. Okay, so this is a pretty cool spot to just stop and think about this. Now we have these little circuit boards, and there's a signal out that tells us what the state of each of these switches is. And there's no computer involved, right? And so now that signal can drive just about anything. It can drive a relay, and the relay could change a semaphore, it could turn lights on and off, and of course if it drives our signal controllers, all different kinds. We're going to install the Dwarf signal controller using this system, and we'll get that working for each of the three switches. So whatever position the switch is in, it will show on the Dwarf. And then we're going to interlocks and configure the signal controller so that when this switch is straight, all of the lights for these two switches have to be red because there's no exit. That's the concept of interlocking. So what I'm going to do, I put some duct tape, double stick foam tape here, and I'm just going to fasten that in front here and likewise over there, and we'll get the signal controllers out next. Okay, what I've done now is I've installed our brackets for the signal controller. The signal controller will snap on like that. And I've also added one of our power modules down at the end of the board. And just for convenience and power wire management, I've drilled a hole in the layout for the power wire, ran it down under the board, and connected up. I've got one connected already, and then I've got two wires for the remaining two signal controllers. So, but we're going to focus on this setup right here, right there, first of all. Okay, so the coil detector comes with this wire, these two wires, and a yellow wire attached already to the coil detector. I took it off in the earlier video just to keep things clear as to what we were working on. So what we want to do is connect the coil detector to trigger the signal controller. Now, we're going to get into interlocking in, as I said and teased a few times. The first thing I'm going to demonstrate, though, is how to control two groups of dwarfs and two turnouts from a single signal controller. This actually has two independent circuits on it, and so if you're not doing interlocking and just trying to run two turnouts, this is perfectly fine. And into the fiber holes, I've put some other kind of fiber, and I've coated the end with green, red, so you can see what's going on there. And so the first thing to do, the detect, in this case, there's going to be the first terminal here is going to be detect number 1. The one above it is going to be detect number 2. And this is the ground. Now the reason we have a ground, we have two independent power systems. We have the one for the switch turnouts and the coil detector, but we're going to run the signal controllers off of the power module. And in order for all of these things to talk to each other, we need a common ground. So on the coil detector is a second terminal. And what I've done here is I've just created a little pigtail of black wire, keep myself sorted out. And I'm going to just stick that into here. And the first thing I'm going to do, I'll turn the power off for the time being. And I'm going to just connect the ground wire from the ground side, which is the closer to you side, to the ground side on the signal controller. All right. And let's see if I can get that in there. There we go. And the second thing to do is to connect. So I'm going to connect to this switch, turns this turnout. So I'm going to use detect number 1, and I'm going to put that in there. And now you can see why having the magnetic bracket is really a good idea. All right, so we'll just leave those wires there. Hopefully that looks clean enough. And we're going to plug in the power. And a little bit of juice still left in the system. Oh, this is coming from the power module. So let's turn on the coil detectors and all the rest of the power. So now I can turn the switch here. You see the coil detector light, green, red. And what you'll see here is on the left-hand side is the dwarf signal would be changing from green, and then back to red. Red would be thrown. Green would be closed. All right, so that's the first one. All right, what we're going to do is connect the second switch here, and we're going to connect it around to the signal controller. We'll use a common ground. We're going to run the common ground from here to here just to keep the wiring to the signal controllers a little bit easier to manage. Oh no, we'll just run it that way, and you'll see the signal, how the wire's hooked up in just a second. All right, so we've taken the second coil detector and we've added the ground wire and the signal wire on. And for convenience, the ground wire, all the ground wires on this side have to be connected to each other. Whether you connect it here, so these two ground wires are connected to the ground, we could have run this wire to the ground on the signal controller and likewise, or we could have a common bus or terminal, just as all as the signal controller side grounds are connected to the ground side of the coil detector. Now, on the signal out of the second one, the signal of the coil detector number 2 comes around here and goes into the second, so 1, 2, so the middle terminal is the second detect, all right? So now this signal controller, this one signal controller is connected to these two switches and these two turnouts. So dwarf signals controlled by here, number 1, and dwarf signals controlled by number 2. This is pretty much the simplest configuration. So let's test it out. I'll aim this at the camera so you can see what's going on. And you can see the turnout, and you can see the left two fiber outputs changing from red to green. Now if we go over here and hit the second switch, you can now see that the second coil detector is driving the right-hand side. So these are the two circuits, and you'd have that connected there. So that's pretty simple. That's the basic configuration. And all you do is you take the pins, hook them up into the signal controller, and you've got one signal controller. For each turnout switch, you need a coil detector. And when you order or when you purchase the dwarf signal controller, it gives you an option of 1 or 2 coil detectors, depending on what your configuration is. All right, wanted to show you that. Now we're going to disconnect this a bit because when you go to interlocking so that each switch is talking to the next one, you need a signal controller per switch. So we're going to have to add one here and add one down here. All right, I've completed the wiring. I disconnected the signal wire from number 2 when it was going into the first signal controller. I've added another signal controller, and the ground wire now will go to this signal controller. And likewise on a third over here we have the coil detector, signal and ground wire going to their respective inputs on this one. So we've got 3 independent Dwarf controllers, and just like we set up for this one earlier, this will just operate independently. You can see the light going back and forth there. Then this one is in sync with this switch, and likewise this one with this switch. Now I've put fiber pins in the other 2 holes just to block the light to make it a little bit easier to see what's going on there. Okay, so 3 independent switches. You could set it up this way and everything will work great. No problem at all. Now, the reason we need a signal controller for each turnout when we go to interlocking is that we're going to use the second terminal, that middle one, to trigger the interlocking. And so what that will mean is while this shows green right now, if this turnout goes straight, that blocks the exit for this. And while it's still green now, it should be red because it cannot exit through this switch. That's the interlocking concept. Likewise, so when this switch is sort of the master switch is set away from the siding, all the lights on the siding should be red until there is a clear exit. And so it'll depend on which switch you have, but that's how we're going to use interlocking. So we're going to run a wire from, we'll just do 2 switches right now. It's pretty simple to do 2. We'll run from the trigger to the interlocking pin, and we'll configure this controller for interlocking so that it responds to number 1. And to do that, we have a cheat sheet. Let's get that out, and which comes with the documentation, and we're going to go into interlocking mode, and that is 8 pulses. So we'll do that. Let me get the wire hooked up, and then we'll go to configure this. All right, I've connected the detect signal, so the signal that's coming from the coil detector for signal controller 1, so this switch, to the detect side, to the interlocking side, which is the middle screw here. And we're going to use this chart, and interlocking mode is 8. So we press this 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And what that means is instead of having 2 independent circuits, we have 2, these are all part of one light setup. So the dwarf signals now are red and green to match the switch. Now, at the moment, the turnout on the other side here is straight. That means that the exit is blocked. These should be both red. Let me just flip this so you can see what that looks like. In other words, that's the way it should be. But this is backwards. All right, so this is saying, okay, I'm going to do the turn here. Now I should be able to have a red and green depending on which way this switch is. So that's backwards. The way to correct that is to simply go over to your first coil lines. So these are the coil lines sensor, and reverse them. And that will make closed and thrown for this sensor backwards, okay, or reverse. So now the light is a different color, and likewise before we had green as straight and red as thrown, and now they're backwards. Well, guess what? The cool thing about the fiber system is I can just reverse the wires and make it line up. So now closed, meaning straight, is going to show a green fiber over here and red going this way. You can, if you want to make it different, but what's important about that is when this one is closed, the exit's blocked, now you see that both of these turn red. When it's released, it goes back to whatever the position of this switch is, which will go back and forth. So that's the essence of interlocking. Regardless of which position this is in, if the exit is blocked, they both turn red. All right. So let's say this turnout is now thrown. Let's put it into the closed mode. let's put turnout number 1 into closed, meaning the exit's blocked and both lights here. So that's interlocking with 2 turnouts. And that's, if you just have 2 turnouts and you wanted, that's all you're going to do, that's as far as you need to take it. The next level of complexity and intricacy of this is that when you add another turnout, you want this turnout to be dependent on the second turnout and the first turnout, right? In this first case, we had just one turnout dependent on one other one. We just wire the wires together. Now we'll have to figure out by adding our diode board how to get this switch and this switch to sync up. So it's possible that this switch is, the exit's clear. You come to this switch and this switch is thrown. All right, so this switch had a green and red, but now if this switch is thrown, this switch doesn't have a clear path to exit, and both its dwarf control lights should be red. This will be red or green, this will be red or green. So we'll show you how to do that next. All right, we're going to talk in theory about the interlocking when you have more than just the 2. So only have one interlocking controller and you don't need anything special. It's the hookup we described. But if you have a second one, what we want to happen is this controller, number 1, to send an interlocking command to these 2. All right, so you'd think, okay, we got 1, so we'll just connect a wire to 2. What that will cause, however, is these things will be all linked together, and this one won't act independently of this one. In other words, we want interlocking message from this going here and this going here independently. We don't want the wires to connect. And so we can use the magic of a switching diode. And what that'll allow it to do is the signal to go from here independently and from here to here independently, but allow these to operate separately when they need to. Now, diodes have a direction, and there's a little mark on there, but let's say that you're not really clear on that and how that works and which way it should go. It's in the documentation, but here's the simple one. Before you hook up anything else and get more complicated, get one setup working, just like we have here. Then disconnect the interlocking wire from this one and put the diode in. So let's back up a second. When we have interlocking on, I think you can see that these are both red. So this switch is closed, there's no exit, so both of these should be red, all right? So when we add the diode, we should have the same effect on this one. So I'm going to just put this diode in. Actually, I'm going to cheat a little bit. I'm putting it in backwards. So you can see that adding the interlock, I'm just going to hold this wire, causes no change here. So we know that's not the right direction. All right, so we're going to unhook this, reverse this diode, and put it in. And then I'm just going to hold this wire on here, and you can see that now it's interlocking. So now if I look at the diode, oops, sorry about that. If I look at the diode is facing that way. In other words, the black line and the arrow is going to go like this. So the black line is going to be on the left, and all we have to do is connect to here. All right, so that's good. Now what we want is we want this signal controller to connect to the output of this one, because if this is blocked, we want this one to go red, but this one to act independently. And if this one is blocked, we want this one to go red. So we need 2 diodes connected to this one. When we have what would be a third interlock, a fourth switch, that one will need to have 3 diodes. And if you have another one, you'll need 4 diodes. And pretty soon it gets a little complicated sticking these little diodes in. So guess what? We have a little diode board where you can connect up, and we'll show you that later. We'll just replace the diodes with it. But there's 4 per board. You can really get sophisticated. You could have 2 if you have an extensive switching layout, and you just connect these up over here, and then to each of the signal controllers downstream or upstream as you need to. So what we're going to do is we're going to connect up. We got 1 diode here, and we're going to connect 2 diodes here and run a wire from each of these, 1 to here, to the detect side, and 1 to here. So that's going to take me a couple of minutes to do that, but I'll show you when I'm finished. All right, let's review what we've done. So we had one master, or the main switch, so this is to the main line, signal controller. No changes to the configuration, just leave it as it is. It does not have to be in interlocking mode, just operates. We did switch the wires and switch the outputs so that the trigger for number 2 would work properly. We just have the trigger wire from the coil here that tells this signal controller to change colors. It also tells this signal controller on the interlocking mode if this switch is clear or not. So we had that before. So right now this is showing clear, which means that this switch is facing this way and it can turn. So when we switch to the closed, you can see that it both change to red. That's the behavior. It doesn't matter what position this switch is in, it's going to stay red. Now, one of the things is inside this little coil detector, we keep track of what position this switch is in, even if the lights are different. So if we switch back, you can see that there's now the outside red, inside green. Interlock mode, change this switch and release it, you'll now see that we have green and red. So even though it's interlocked and the display shows, if you switch the switch, the coil detector keeps track of what position it is, even if it's locked. Okay, so that's really cool. All right, so now that works right out of the box. So that like I said, once we add a second one and we want it to have interlocked back more than one controller interlock, we're going to have to add the diode. So we did this one and made sure that this worked before we connected anything else. As I mentioned before, we'll need 2 diodes. And the number of diodes really is related to how many signal controllers or coil or switches do you have before this that could impact whether there's a clear path to exit. So right now, this switch over here is set to the turnout. This switch is set to this siding, not straight, which would mean that this should be red. And guess what? It's both red. If we change this to go straight, you'll notice that this controller now can show its true aspect, whether it's red or green. And that's exactly the behavior that we want. Now, what gets a little dicey as you go through this is I have now the coil detector signal going into the detect, and now I've got to detect from each of the signal controllers downstream, and I was just barely able to fit the 3 wires in here. We do have so there's 2 solutions to this. One is, as I mentioned, if you have only 2 signal controllers or switches before this, you can get away with 2 diodes like I did here. When you get to 3, you really need our diode board, and simply you run a wire from here to here, and then you've got 4 diodes on the board, and you just run them to individual switches. What happens, however, downstream is that you can imagine that each starting with the first switch, this is going to have a wire from every one of the controller switches downstream, and that's going to not be possible to plug in here. So we have this little connector board, and it's simply a terminal board. There's no electronics on it. You plug a wire from here to here, and then you connect each of these signal wires that's coming from the upstream controllers to this. So that's just a great way for wire management. And then the other thing, you could have the diode board here to replace a single diode. A little bit of a waste. I think you can get away with 1 diode there. However, the advantage is that you don't have to solder things. So I just did a quick point solder joint on each of these things. That was really easy to show you how the diode setup would work. But if you use the diode boards and the terminal boards, everything is screw terminals. There's no soldering required whatsoever. So that's the layout of the setting up the coil detector just for the turnout, setting up 2 switches with 1 signal controller. We did that. Then we went to interlocking, so we'll need a signal controller for each turnout. We got 2 working without the diode because there's just 1 downstream and there's no conflict with the second one. Then we added a second controller, which required us to put these switching diodes, which blocks the conflict between, it sort of just becomes a boil of spaghetti if you don't have the diodes in there. So that helps you protect that signaling. that's the way it works. And if you have any questions, feel free to email me at support@modeltraintechnology.com. All right, this is a view from another camera angle. We're shooting down the layout, if you will. And as you can see, each of the controller lights are set up. Right now, this primary switch is headed towards the siding. That means that this switch is live and this switch is live. So this is all the way down, set to closed. So now this controller is dependent on these two controllers. So what we can do is if we change this so that it goes to this siding, then this switch is blocked, and you'll see what happens. Both red over here. And no matter what you do on this switch, it's going to stay red until there's a clear path, and there's only going to be a clear path unless this switch is changed and that this switch is to the siding. So in fact, if we go back to this switch and make it straight for the mains, all of the siding lights will turn red because they don't have a clear path to exit. Now the coil detector continues to monitor which position the switch is in. So even if you move the switch, okay, so now it's to the siding. When we release this one and head it towards the siding, now this is showing going to the siding. This one's still red because this is going to the siding. If we now move this straight, okay, now we've got a clear path for this switch, and then we can activate whichever direction this switch is going to go on. So that's a pretty cool setup. I didn't install all the little dwarfs. This was an easier way to demonstrate it with the little plugs in it. But you would put the dwarfs along here, and it would make a great setup. So that's how you connect it up.